Hi guys, welcome to my channel. Today I'm going to solve this problem DFS of graph, DFS depth first search. So as you all know that there are two kind of traversal which we can perform on graph, BFS and DFS. BFS I have already recorded. Now it's turn to record DFS. The main motto of solving that DFS is not to like write the code and tell you like this is how it is working, but to actually see that the recursion calls, like recursive calls, how recursion is like moving forward from one node to another and how it is storing it in the answer. So let's see how it is working. Okay, so let's move to this. Now I have created an adjacency list, nothing, just it is given 0. From 0th index we can move to 2 3 1, from 1 we can move to 0, that I have created here. Now let's start the traversal. Now we are for traversing in this graph we need two things. Okay, we need two things. First one is visited. Okay, let me change the pen. First one is visited, and the size will be the number of nodes we are having, and our answer vector. Okay, so visited will be 0 1 2 3 and then 4. Now let's start iterating. So currently we are standing at 0th position. Okay, so what are the nodes we can go from 0? We can see that we can go to 2 3 and then 1. So recursive call will goes like from 0 we will move to 2, marked 2 at as visited. First we will be marking 0 as visited because from 0 solve 0 we have called s of 0. Now recursion call will go s of 2. Okay, now what are the next nodes we can visit from 2? We can see that from 2 we can visit 0 and 4, but 0 is already visited because we can see here 0 is already marked true, so we will not be moving with 0, we will moving with 4. Now the call will go like by the way, I am not storing it in the answer, I should store it. Let's not make it. So I'll be pushing 0 then 2. Now it's turn to call 4, s of 4. Now we'll go to 4. We'll see that from 4 where we can visit. Okay, I have mistakenly write this. This is typo. From 4 we can visit to 2. Okay, now let's see from 4 where we can visit. From 4 we can visit to, by the way 4 is marked true. From 4 we can visit to 2, but we can see that 2 is already visited, so the call will not go 4. We have to store it in our answer and it will return back to 2. Now we have already visited 0, we have already visited 4, this also complete, 2 also completed. Now 2 the solve function of 2 is also completed. Then what we will do, we'll backtrack, means return back to 0. Now it's turn of 0. From 0 we have visited 2. Let's see, is 3 visited? No, 3 is not visited. Then mark 3 as visited, put it in our answer, and then from 2 we call to, from 0 we call to s of 3. Okay, now 3 is also visited. Now from 3 we can see that where we can go. From 3 we can move to 0, but 0 is already visited, so no need to visit it again. Now we will be visiting, we'll be moving back to 0 because we have traversed all the nodes of 3. From 3 where all the nodes we can visit. Now again back to 0. Now we can see that only one node is pending, which is 1, and it is also not visited, so we will be explaining it s of 1, marking 1 and 2 and pushing it in our answer 1. So 1 is also marked true and 1 it is in our answer. So by this we have visited all the nodes. So let's see, one thing I have to write before like moving to any of the node, we are performing two operations, like mark the node visited and push that node in our answer. So this is the way we are going to solve this. So answer is 02431, 02431. So let's see what I have done in the code. I have initialized vector of visited. Initially it contains v vector, v nodes, and all are marked false because no one is visited, and an answer vector. Now created a solve function, passed 0 because this is the starting node, adjacency list, visited, and answer vector to store all the answer. Now after calling the solve function, we have the current element u. What we are doing, we are marking it as visited and pushing it in our answer vector. What I've told, mark the node as visited and push the node in our answer vector. Now what are the nodes from u we can visit? Check in the adjacency list. Putting 0 in the adjacency list, it will give 0 in the adjacency list, it will give 2, 3, and 1 in the v. Like if v is not visited, then again call the solve function for v and explore further. So this is the way we are going to solve this problem. So thank you for watching.